Questions 11 through 20 on the 2014 Grade 10 AMC 10A. A customer who intends to purchase an appliance has 3 coupons, only one of which may be used. Coupon 1, 10% off the listed price if the listed price is at least $50. Coupon 2, $20 off the listed price if the listed price is at least $100. And coupon 3, 18% off the amount by which the listed price exceeds $100. For which of the following listed prices will coupon 1 offer a greater price reduction than either coupon 2 or coupon 3? All right, let's figure this out for coupon 1, coupon 2, and coupon 3. Well, coupon 2 is the easiest because it's just a flat 20 bucks off. So the discount here is $20, $20, and so on. Nothing needs to be calculated. So that's good. Saves us a little bit of time. Now let's look at coupon 1. Coupon 1 is 10% off. Okay? And all of these are greater than 50, so 10% off. Okay, so 10% off, let's just round it up. This is $180, so 10% off, that would mean a savings of $18. 10% of $200, $20. 10% of $220, $22. 10% of $240 is $24, and 10% of $260 is $26. So those are the discounts there. Now we go to number 3. 18% off by which the listed price exceeds 100. So we have to take 100 away from these prices and then take 18% of that. So for the first one, it's 180. We got to take $100 away, leaves me with 80. And I've got to take 18% of that. So 18% of 80. So 0.18 times 80. And that's approximately 14 probably, somewhere. So you get the idea. And the same thing, 18% of this guy, which is going to be 100. So that's easy. That's $18. And then similarly, 18% here of 120, which is approximately 21 point something, 21.6 probably. And then 18% of 140, which is 25 point something, 25.2. And then finally 18% of 160, which is 28.8 approximately. Okay, so now which scenario does coupon 1 offer the greatest discount? For this one, no, this one. I'll circle the one that's largest in each category. Here there's a tie. Here it's coupon 1. Here it's coupon 3, and here it's coupon 3. So the one they wanted was when coupon 1 is the greatest price reduction, and that is for choice C, for number 11. A regular hexagon has side length 6. Congruent arcs with radius 3 are drawn with the center at each of the vertices, creating circular sectors as shown. The region inside the hexagon but outside the sectors is shaded as shown. What is the area of the shaded region? All right. So a couple steps here. The area of the shaded region is obviously going to be the area of the hexagon minus these circles, or parts of the circles. And there's 6 of them, right? There's 6 of these circle parts. But the internal angles of a hexagon is 120. And if you didn't know that, you can just figure out that a hexagon is basically 4 triangles. And each triangle is 180. So 4 times 180 is the total amount of angles. And then there's 1, 2, 3, 4, 6 internal angles. And if you did that math, that would come out to 120. But I'm sure you remember that the internal angles of a hexagon is 120. So that means that 120 degrees is going to give you an idea of how much of a circle each of those segments is. Well, the whole way around is 360. So those segments are 1/3 of a circle. So 1/3 of pi r squared is each circle, but each segment, right, these arcs, and there's 6 of them. So I got to multiply that by 6. So this is my formula. Simplify this a little bit. Area of the hexagon, which I'll calculate in a minute, and this is going to be 2 pi r squared, and pi, they told me, is 3. Or sorry, pi. Radius is 3. Pi is actually close to 3, but the radius is 3. Okay, so we've got area of the hexagon, and then this is going to be 18 pi. So 18 pi is right here. So if you're really brave, you could choose that, but probably not good advice to give. But something tells me that's the right answer, but it's okay. We can figure out the area of the hexagon. So here we go. The area of the hexagon is going to be calculated as follows, and that's a very common question actually. They give you the side length of a hexagon and they say find its area. So what you do is you cut it into parts like this. And some of you actually have memorized the formula. If you memorize the formula, that's perfect. Go for it. I just want to explain it for those who have not memorized the formula. So this is 6, and this is 6, and this is 6. And this was 120, and then when I draw a rectangle like that, that becomes 90. So this angle in here is 30. And this is, of course, a right angle, the way I've drawn it, so that's 60. So we've got this 30, 60, 90 triangle, and that will allow us to figure out the sides. All right. So here we go. I'll call this length x, and I'll call this length y. So we all know, I hope, that the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. The ratio of the sides, not necessarily the lengths. So using that, we can figure out x and y since we know one of the sides, an integer actual value. So x over 6 is the same as root 3 over 2 using those ratios. So x is basically 6 over 2 root 3, which is equivalent to 3 root 3. And then we do the same thing to figure out this y right here. So that means y over 6 is the same as 1 over 2, and that very quickly gives you a value of 3 for y. All right, so now we can figure out the area of the hexagon. That's going to be, first let's look at this rectangle. So that's length times width. So the length is 2x, and x is 3 root 3, so that's 6 root 3. And then the width is just 6. So that takes care of that rectangle. Now we have to add these triangles. There's 2 of them, and they're identical. So it's going to be 2 times 1/2 base times height, because there's 2 triangles. The base is 2x, which is basically 6 root 3, and the height is this y, which is 3. And that's it. And then, of course, don't forget to subtract that 18 pi. So now simplifying, this is going to be, what, 36 root 3 plus, let's see here, 18 root 3 minus 18 pi. And that is 54 root 3 minus 18 pi. And that's exactly what I had predicted. So number 12, the answer is C. Equilateral triangle ABC has side length 1, and these squares lie outside the triangle. What is the area of that hexagon? Okay, so here we go again. Let's label this. It's 1, 1, 1, and obviously this is 1 and this is 1 since this is the side of the square. So the area of that big hexagon, let's break it up into components. First of all, we got that equilateral triangle ABC. And then I've got 3 squares, and each of those has an area of 1 times 1, so that's pretty straightforward. And then I've got 3 of these triangles, these guys, and they're all the same in terms of their area because of the symmetry of this diagram. So 3 times, I'll just write one of them, AEF. All right, so let's first figure out ABC, and then we'll figure out AEF, and then we'll put it back into our formula. Let's first concentrate on this ABC triangle. So very similar to a lot of these questions, we again have a situation of a 30, 60, 90 triangle. And instead of boring you to death, I'll just write it in. So if this is a half, because this whole thing was 1, right? We are going to be able to calculate the lengths with the 30, 60, 90 ratios. So this is going to be root 3 over 2, and the side over here is, of course, just 1. So that area for ABC is 1/2 base times height. The base is 1, and the height is root 3 over 2. And then, of course, those squares just become 3, and then 3 AEF. And now AEF is what I have to concentrate on. So here is our EFA triangle, and we have to figure out the area of this. And in a very similar way, we cut it in half, and we notice again it's going to be one of those 60, 30, 90 triangles, because remember, this is going to be 120. Since this is 60, these are 90s, this is going to be 120. So that's how I know that's 120. When you chop it in half, it puts 60 on each side. So again, I'm sure you could do this. AF is going to be 1, since it's right here. And then we can figure out the other sides. And when you do, you get that this from here to here is going to be root 3. And this height is just going to be a half. So it becomes 1/2 base, which is root 3, times height, which is a half. So adding all this up, we get root 3 over 4 plus 3 root 3 over 4. And that looks like 4 root 3 over 4 plus 3. And that is root 3 plus 3. So the answer is right here. Number 13 is C. The y-intercepts P and Q of two perpendicular lines intersecting at the point 6, 8 have a sum of 0. What is the area of APQ? Let's draw a basic diagram to illustrate what this question is referring to. So we have a situation where you have two lines. So let's say one line is like this, and another line is like that, something. And obviously they're perpendicular, so they've got this right angle. And they intersect the y-axis at here and here. Now they're saying that where they intersect, the sum is 0, in particular the y-intercept. So these points are obviously of the form 0 something. So for example, this would be 0p, let's say. Well, and that is p. And this is q. But since this is a situation where the sum is 0, p plus q equals 0. So that means q is equal to minus p. So instead of q, I can just put minus p there, like that. All right, so that's the first step. And now what we have to do is figure out what is p. Because this point right here, we know they've told us that is 6, 8. And obviously this is certainly not drawn to scale, but that's okay. And once we get that, we can then figure out the area of this triangle. That would be pretty straightforward. It would just be a 1/2 base times height. All right, well, let's call this line 1 and let's call this line 2. We'll find the equations of both lines, and that will allow us to figure out P pretty easily. So let's start with L1. L1, like any line, will have the equation y is equal to mx plus b. So substitute this point since it's on it, and that would give me p is equal to b. And then substitute this point since it's on it, and that would give me 8 is equal to 6m plus b, but b is p. So therefore 8 minus p over 6 is equal to m. And therefore that equation is y is equal to 8 minus p over 6 plus p. That's the equation of L1. So I'll put that there, L1. There we go. So now do the exact same thing for L2. L2 again is going to be of the form y equals mx plus b. L2, we can now plug in that point, and when we do, we get minus p is equal to b, and then plug in this point, since that's also on that line, and that means 8 is equal to 6m plus b, but b is minus p. Solving for this, we get 8 plus p over 6 is equal to m. So therefore, the equation of L2 is y is equal to 8 plus p over 6 minus p. And of course, we got to put in the x's there. Can't forget those. All right, we have made quite a bit of progress here. Let's make some space for ourselves. Now, at this point, you have to understand that these two lines are perpendicular. So that means that their slopes are negative reciprocals. So this guy and this guy are negative reciprocals. So what that means is that when you multiply them, they will equal negative 1. So 8 plus p over 6 is equal to negative 1. That's what negative reciprocal means. It's usually m and then negative 1 over m. Those are the forms. So if you multiply them together, they would basically give you negative 1 as an answer. So that's what this is going to give me. So this is 64 minus p squared is equal to negative 36. So that means 100 is equal to p squared, and therefore p is 10. And there we go. We got p, and now we can figure out the lengths. So this is 0, 10, and this is 0, minus 10. So now I can figure out this length and that length, and I can then figure out the area. So first, let's figure out that length. We can easily do that. I'll call this b, and I'll call this h for base and height. This is b, and this is h. So h is going to be, using the distance formula, 6 minus 0 squared plus 8 minus 10 squared, all under the square root sign, and that gives me 36 plus 4, so root 40 is h. Okay. All right, great. Now let's figure out b. b is going to be 6 minus 0 squared plus 8 plus 10 squared, and that's going to be 36, and then 18 squared, 324. So b is therefore going to be the root of 360. And now all I have to do to figure out the area is 1/2 base times height. So area is 1/2 base, which is root 360, times height, which is root 40. And when you crunch out these numbers, you get 60. And then for number 14, the answer is D. David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes that he will be 1 hour late if he continues at this speed. He increases his speed by 15 miles per hour for the rest of the way to the airport and arrives 30 minutes early. How many miles is the airport from his home? Well, we have a situation where he's driving and we don't know the exact distances, but his home is here and his airport is here. And for the first 1 hour, so let's just say approximately that much, 1 hour, he drives at 35 miles per hour. So obviously that means he covers 35 miles. And then he's going to drive the remainder of the distance at 50 miles per hour because he wants to ensure that he is not late. So throughout this question, we're going to use this formula. Speed is equal to distance over time. And here we go. So the first part of the question tells me that he's driving 1 hour at 35 miles per hour. So obviously he covers 35 miles. Now, that question, or that part of the question also lets me know that if he drove the entire way, so I'll let the entire way be D. So if he drove 35 miles an hour using this formula, he would actually be 1 hour late. So it would be t plus 1, where t is that perfect time that allows him to reach the airport in time. So that's what this equation is based on the first part of the question. So we can write 35 is equal to t plus 1. T times 1 is equal to d. Now we get to the second part. The second part says that if he's driving at 50, then he's going to be actually getting there early, 30 minutes early. So this part, d is now from here to here. So it's d minus 35 actually, that distance. And the time he's going to actually have initially t minus 1 because 1 hour has already happened. And then in addition to that, he's another 30 minutes early. So minus a half for that 30 minutes. So this is the setup of the question. We got this and this, two equations, two variables, and we can solve. So here we go. So this cross multiplying becomes 50 times t minus 3 over 2 is equal to d minus 35. And therefore 50t minus 75 plus 35 is equal to d. And now I can just set them equal to each other. Since d is equal to that and d is equal to that, I can set them equal to each other. So that means 35t plus 35 is equal to 50t, and that's what, minus 40. So that means 15t is equal to 75, and therefore t is equal to 5. So t is equal to 5, sub it back into any of those guys, and when you do, you get d is equal to 35 times 5 plus 1, which is 6 times 35, which would be 70 times 3, which is 210. So the total distance is 210, and therefore number 15, the answer is C. In a rectangle ABCD, AB is 1, BC is 2, points E, F, G are midpoints of BC, CD, and AD respectively. Point H is the midpoint of GE. What is the area of the shaded region? All right, so what I'm going to do is put it on a coordinate axes. So I'm going to write this one, and of course those are behaving as my y and x coordinates, coordinate axes I should say. And now my goal in this question is to figure out the equations of two lines. And those two lines are this guy right here, that's line number 1, and that guy right there. So I'll draw those in blue. When I figure out the equation of those lines, then I can find their intersection point, which is right there. And when I get that point, that is going to help me figure out the area of that shaded region. And the reason is because it will allow me to figure out the base and height of those two triangles. So for example, if I cut those two triangles in half like this, once I get that point, it will allow me to figure out the areas of those two triangles. So first let's figure out the equation of L1, that one right there. So here we go. As always, the equation is of the form y equals mx plus b. And let's label some points that we can sub in. Based entirely on the question and the information given, nothing that I'm adding, this point right here, C, is going to be 1, 0. This point right here. And then this point up here, H, is a half 1. And I will also add B, since I'm going to need that. That's going to be 1, 2. And one more point down here, F. And that is a half 0. So I'll just put that a half 0. Substitute this point when you have y is 0, x is 1, and therefore I can have that substituted in, and that immediately gives me that m plus b is 0. Substitute this point and we get 1 for y, x is a half, so we have m over 2 plus b. And then these two equations, just subtract them and you get negative 1 is equal to m over 2, and therefore m is negative 2. Substitute that back into here and you get b is equal to 2. So my equation is y is equal to negative 2x plus 2. All right, that takes care of L1. Now let's do pretty much the exact same scenario for L2. L2 is up here, that guy. So let's substitute in this point. When I do, I get 2 is equal to x plus b. And then I will substitute in this point. And when I do, I get 0 is equal to m over 2 plus b. And that should be m actually. All right, so same kind of thing. We've got a couple equations. Let's subtract them. And that gives me 2 is equal to m over 2. And therefore, m is equal to 4. Substitute it into either of those. And we get b is equal to minus 2. And therefore, that equation is y is equal to 4x minus 2. All right, we got two equations. Now all we have to do is set them equal to each other. Setting them equal to each other, let's see here. We can do that here. So we have minus 2x plus 2 is equal to 4x minus 2. And therefore, 4 is equal to 6x. And therefore, x is equal to 4 over 6, or 2 over 3. So this point, this all-important point, is 2 over 3. And then we need the y-coordinate also. Substitute that into either one of these. And when you do, you get the y-coordinate is also 2 over 3. If you substitute x equals 2 over 3 into either of those. Okay, so now let's talk about this now. That means the distance from here, if we were to draw the line down, let's say we draw a line completely directly down to the x-axis, that means the distance from the origin to here is 2 over 3. The distance from here to here is a half. So we can quickly figure out the distance from here to here. It will basically be 2 over 3 minus a half, which is 1 over 6. So that means that since this distance from here to here is 1 over 6, and if you were to draw another line, it would probably make a little bit more sense as to what I'm about to say. You'll notice that since this is 1 over 6, this is also 1 over 6 from here to here. So from here to here is 2 times 1 over 6, which is 1 over 3. That distance from there to there. And then now we have to figure out the heights. Well, the height from here to here is the y-coordinate, 2 over 3. So that's 2 over 3. And then the height from here to here, well, that is easy to figure out because from here to here is 1. They even labeled that. And from here to here is 2/3. So from here to here must be 1 minus 2/3, which is 1 over 3. All right. So we are now in the final step, which is figuring out the area of that shaded region. So that's going to be pretty straightforward at this point. The first triangle, which is that small guy, plus the big triangle, which is down here, bigger triangle. So it's 1/2 base times height for the small guy. So the base is 1/3 and the height is 1/3. And then the larger one, it's 1/2 base times height. The base is also 1/3, but the height of that is 2/3. So that gives me 1 over 18 plus 2 over 18, which is 3 over 18. And then in lowest terms, that's 1 over 6. So number 16, the answer is E. 3 fair 6-sided dice are rolled. What is the probability that the values shown on 2 of the dice sum to the value shown on the remaining dice? All right, so like any probability question, it's going to be a fraction usually. And the denominator is the total number of cases. Well, there's 3 dice, so we have 6 choices for the first dice, 6 choices for the second dice, and 6 possible outcomes for the third dice. So that's our denominator, basically. And our numerator, that's what we have to figure out. Okay, so here we go. Since there's not that many, I'll write them all out. So for example, for the first dice, I can have all 1s. And for the second dice, I can have 1, 2, 3, 4, 5, 6 like that. And since for the first two at least there's just 36 of them, I'll write them all out and then I'll come back and talk to you. All right, so now these are the 36 possible outcomes, right? We got to write out the sums. So what is the sum? Well, if 1 and 1, it's 2, 3, 4, like this, right? So I'll just write out all the sums. All right, so what they're saying is when you roll 2 dice, the sum of the numbers have to add up to what's on the third dice. Well, what's on the third dice, first of all? It can be either 1, 2, 3, 4, 5, 6. So let's circle the sums that could match. Well, this could match, this, this, and this. Can't have a 7. The numbers here on the third dice are only 1 through 6. This could match this, this, and this. These could match these two and this. Any other sum is too large for what could be on one dice. Okay, so let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So that is my answer. And if I reduce that to lowest terms, I get 5 over, dividing top and bottom by 3, right? So 5 over 72. Okay, now I look at the answer choices. And interestingly, 5 over 72 is not one of the answer choices. So I think, well, okay, what did I do wrong? Well, I didn't do anything wrong, but the reason the answer is not 5 over 72 because of the following. I'll give you an example to illustrate. Let's say my first dice, I have a 1. My second dice, I have a 1. And my third dice that I roll, it gives a 2. 1 plus 1 does indeed equal 2. So that's a perfect scenario, right? But the question did not say it has to be in this order. It could also be like this, 1, 2, 1, or it could be 2, 1, 1. Notice the wording in the question. The value shown on 2 of the dice sum to the value shown on the remaining die. So you notice this also qualifies, this scenario, because 1 plus 1 is equal to 2. This also qualifies because 1 plus 1 is equal to 2. See what I mean? So basically what I did was I undercounted, interestingly. I have to multiply my answer by 3 since each scenario that I wrote has 2 other possibilities. So this has to be multiplied by 3. And when you do, you get 5 over 24. And 5 over 24 is the right answer for number 17. A square in the coordinate plane has vertices whose y-coordinates are 0, 1, 4, and 5. What is the area of the square? Let's draw a coordinate axes and let's try to figure out what we can do with this question. So the coordinates are something like A0 and then B1, C4, and then D5. So they gave me the y coordinates, but they didn't give me the x coordinates. So I got to figure out how this square looks first of all, and then I've got to figure out the side length. And once I have the length of the side, I can easily figure out the area. Okay. All right. Ooh, where do I begin? Okay, so I don't think it really matters as long as I figure out something that matches. So I'm just going to put the first one here. I'm going to put 0, 0. That's sort of my A. And then B, C, D I'll figure out. For my next one, for B1, well, I don't know what B is, so it's got a y-coordinate of 1, so it's going to be somewhere here. So this is B, obviously. So that's about as good as I can make this based on what. So that's part of the square there. And now I've got to figure out where does C and D go. Okay. Well, I'm not sure, but I think I can use the fact that it's a square to help me. The fact that it's a square, it's going to look something like this. Obviously, something like this. Probably not the greatest diagram, but something like that. So that means that this, if this is B, which is B1, the coordinates, and this has got to be C, which is, or probably, based on this diagram, this is probably going to be C, since that's 4, and this makes more sense that it would be 5, because if this is 5, then 5's here, right? And this is 4, 4 is here. So based on the way I drew it, I've got to match things up. Okay, no problem. Well, now I got to figure out how does this work here. I'm going to compare this point to that point. The fact that I got B, I went this way, B, and I went up 1. So this is B, the length. And I'll just write it here, and this is 1. Therefore, to go here, I've got to do pretty much the same thing. That's how squares work. So I've got to go up, this time B, and I've got to go across by 1. So if I go up by B, that means the y-coordinate has got to be B, right? If got to go up by B. So from here to here is B, and across has got to be 1. So I hope that makes sense. So that means the y-coordinate has to be B, and the x-coordinate has to be 1, but the x-coordinate is on this side of the axes. It's in this quadrant, so it's -1. So that basically means that my B is 4. So that means this is equal to 4. Okay, that really helps, because now I can figure out the side length. Side length using Pythagoras will be 4 squared plus 1 squared. So S is equal to 16 plus 1, which is 17 root. And therefore S squared will be root 17 squared, since I want to get the area, and that is 17. And that is, of course, the area. So number 18, the answer is B. Four cubes with edge lengths 1, 2, 3, 4 are stacked as shown. What is the length of the portion of xy contained in the cube with edge length 3? We want to draw a line from x to y, and then we're going to figure out that distance. And if I draw a line from there to there, and you will notice hopefully that this is going to be a right angle, and therefore I can use this triangle to figure out xy. Well, this part is the easiest. It's just 1 plus 2 plus 3 plus 4, so that's 10. So that's equal to 10 right there. And then xy obviously is going to be the hypotenuse, and now I have to just figure out that. Well, this is 4 and this is 4, so I can figure out this length, and let's just call this z. So I'll call this yz. Yz squared is 4 squared plus 4 squared. So that's 16 plus 16, which is 32, and therefore yz is root 32. So now I can figure out xy. Xy squared is going to be yz squared plus 10 squared. Or I'll just write it in letters first, xz squared. So yz squared is 32, and xz squared would be 100. So 132 is xy squared, and therefore xy will be 132 root. And root 132 is the length of xy, but interestingly, they don't want the length of xy, they want the length of the portion of xy contained in the cube with edge length 3. So as this line is going from x to y, what portion of that only resides in this cube right here? Well, it might seem a bit difficult, but it's actually not so bad. The portion is identical to the ratio of the sides. So if I asked you, what portion of this length 10 is part of that cube that has a length of 3? Well, you'd say it's 3 over 10. And that's exactly how you'd figure out that part of the question. It's 3 over 10 of this. So 3 over 10 times 132. And 132 is what? It divides through by 4. So 2 times root 33. And then 3 over 10 like that. So that's 6 root 33 over 10. Lowest terms, top and bottom by 2, 3 root 33 over 5. And that is A for number 19. The product 8 times 888 dot 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 8, where the second factor has k digits, is an integer whose digits have a sum of 1,000. What is k? Well, we have to figure out a pattern here. So initially they just give us sort of the general that this is k8s. And they're saying that eventually you're going to have a big long number that when you add up the digits, it equals 1,000. And when that happens, what is k? Okay, we have to look for a pattern. So first let's do k equals 2. And then we'll look at, see what kind of a pattern we have. I think if I do just a few of these, the pattern should be clear. So I don't think I need to do more than 4. Okay, when k is 2, I just have this scenario, 8 times 88. And 8 times 88 is 8 times 8 times 11. And that is equal to 704. Now I have to figure out the sum of the digits of this number, and it's 11. Okay, too early to figure out a pattern, but let's keep going. So now we have k equals 3. Now I've got 3 8s here. So this is going to be 8 times 8 times 111. Not that it really matters what form it is in, but I don't know, for some reason I like doing that. So this is going to be 7104. Now the sum of the digits of this number are 12. Okay, perhaps I can figure out a pattern, but let's just keep going. Now I've got k equals 4. This is going to be 8 times 1111, and that is 71104. The sum of the digits of that number is 13. Let's do one more. I think you probably have figured out the pattern by now, but let's just do one more. When k is 5, this is 8 times 11111, and that is 711104, and the sum of the digits here is 14. Well, you definitely have seen the pattern so far. It seems like, to me, the pattern is that the sum, which is this column, seems to be that has a relationship with these k's as follows, that the sum minus k looks like it equals 9. And I think that's true all the time. I've done it for 4 of them. And, you know, I'm pretty convinced. So let's figure out what k is for when the sum is 1,000. 1,000 is the sum. What is k? Minus k is equal to 9. So that means 1,000 minus 9 is k. And therefore k is 991. So pretty cool question. Number 20, the answer is D.